This is a real monumental event. An invisible yet colossal wave is passing through billions of stars, including our Sun. This isn't some random cosmic wind, nor turbulence from a passing asteroid. This is the galaxy's pulse. Imagine this. You're asleep, and somewhere out there, many thousands of light years away, something so vast is happening that it can affect every corner of our stellar system. A stellar tsunami, not of water, but of gravity, of motion, of energy that permeates every atom. When physicists first started to hypothesize something like this, they probably whispered, "What nonsense is this? The galaxy, breathing, does it have cosmic lungs or something?" And then someone, perhaps with a smirk, replied, "Well, if you want to call it that, go ahead. But it's certainly not sitting still." We're used to perceiving it as a stable home where everything is predictable, but it's a living, bustling, dynamic structure where something is always happening. And this something is an entire wave of starlight, of gravitational influence passing through it, as if an invisible hand is stroking its back, making this entire stellar ocean sigh. Are you ready to discover what incredible secret this gigantic organism holds while we peacefully sleep in one of its tiny abodes? November 1st, 1755, Lisbon, morning. The city sleeps. Nothing foreshadows disaster. Suddenly, an infernal roar. The ground shakes violently. Buildings collapse. But the worst comes later. The ocean, as if recoiling in terror, reveals its floor. And then it arrives. An invisible force, gathered over thousands of kilometers in the depths of the Atlantic, crashes down on the city as a wall of water as high as a multi-story building. A tsunami. Not just a wave, but an entire catastrophe, caused by something no one could see underwater, long before that immense power reached the shore. By the way, if you enjoy diving into the mysteries of space with us, don't forget to hit that like button on this video and subscribe to the channel. It really helps us create new content. And here's something else we're curious about. What city and time zone are you watching our lectures from? Write it in the comments, we'd love to know. Now, back to our invisible wave. So imagine something similar, but on a galactic scale. We're not talking about the headlights of galactic highways here. This is a gigantic, mysterious oscillation that is currently piercing billions of celestial bodies. You know, we're used to seeing waves, on water, in the air, as sound. But this cosmic wave, it's different. It's not invisible because we're not looking hard enough. It's invisible by its very nature. Imagine you throw a stone into a pond. Ripples spread out. We see them. Now imagine you're throwing not a stone, but something that changes the very density of the water around it, causing it to compress then expand without creating any visible ripples on the surface. Or as if you were trying to catch a breath of wind that rustles the leaves on trees. But the wind itself, or rather its physical body, doesn't exist. It's not light, not radio waves, not even gravitational waves in the usual sense, the ripples in space-time born from merging black holes. This is something far more subtle, and at the same time, incredibly powerful. We're talking about a density wave. A region where stars and gas temporarily draw closer to each other and then spread out again, as if someone is compressing and decompressing galactic space. The English mathematician John Adams and the French astronomer Urbain Le Verrier, independently of each other, dared to propose the incredible. Somewhere out there, beyond Uranus, another unknown planet was hiding. Only its gravity could explain these tiny yet persistent glitches. Most colleagues probably scoffed. Are you serious? A planet no one has seen, but it's moving one we've already discovered? It was akin to knowing for sure that an enormous yet invisible elephant lived in an empty apartment just by the faint creak of the floorboards. And so, based purely on mathematical calculations, Johann Galle pointed his telescope to the spot indicated by Leverrier. And what happened? Just over an hour later, he discovered Neptune. Skepticism turned to shock, and then a triumph of reason. Listen, if you're enjoying our cosmic journey, if you feel the universe revealing its secrets right before your eyes, don't forget to subscribe to the channel and hit that like button on this video. Your support helps us continue these incredible stories. And please tell us, what city and time zone are you watching our lectures from? Write in the comments. We'd love to get to know our audience. Now, let's get back to our galactic anomalies, because the story of Neptune was just a warm-up for what was happening in our very own galaxy. You know, the discovery of the Milky Way's breathing began in a similar way, with a tiny, almost imperceptible twitch in the data. Thousands upon thousands of stars were studied by telescopes, their movement speeds meticulously measured. And that's when scientists began to notice something strange. Not just random noise, not an instrument error, but a systemic deviation. As if all the stars in a particular region, not just any stars, but those in the right place, were synchronously moving up, then down, like on an invisible swing. Initially, it seemed, well, outright nonsense. Physicists were like, "What rubbish is this? Are you serious? Stars moving in sync? That can't be. Someone must have poorly calibrated the telescope, or we're just seeing some statistical error." Imagine you throw a bunch of pebbles into a pond. They fall chaotically, each on its own. But then, suddenly, one after another, the pebbles start bouncing in the same spot, creating barely visible yet distinct ripples. And it's not just one or two, but thousands. Many found it easier to dismiss it as an artifact, some unnoticed glitch, because it would mean that the Milky Way isn't just rotating like a giant carousel, but also pulsating, breathing. It changed the entire familiar picture. It took scientists years of painstaking work, cross-checking and re-verification, new methods of data analysis. They literally sieved cosmic sand through a nanometer mesh to ensure they weren't seeing what they wanted to see. And every time they thought they were about to catch this phantom red-handed and prove its non-existence, it would manifest itself again. At first, it was a small group of enthusiasts whose eyes gleamed with the premonition of something grand. They gathered more and more evidence, like detectives searching for clues in the century's biggest crime, a crime against cosmic stasis. And gradually, slowly but surely, skepticism began to give way to wonder. And then, awe. It turned out these twitches were no accident. It wasn't just stars dancing chaotically. It was a giant, ordered wave passing through our galaxy's disk, like ripples on water. Invisible, yet influencing billions of celestial bodies. From "what rubbish is this?" to Nobel-level significance. Such was the journey of this discovery, changing our understanding of the home we call the Milky Way. Imagine this, 1933. A scientist named Fritz Zwicky, working at the California Institute of Technology, was studying one of the largest galaxy clusters in the universe, the famous Coma cluster. He observed how fast these galaxies were moving, and something didn't add up. Their speed was so immense that by all laws of physics, the galaxies should have simply scattered, like water splashing from the wheels of a race car. But they held together. Zwicky, in his inimitable style, proposed there must be some invisible substance, some dark matter, he himself called it, in German fashion, dunkel Materie, whose gravity held all this cosmic chaos together. At first they scoffed at him, saying, "What kind of fantasies are these?" But he was right. He saw an invisible heartbeat caused by something mysterious. By the way, if you like how we dive into these cosmic mysteries, don't forget to subscribe to the channel and hit that like button. Your support helps us move forward and uncover new, amazing stories of the universe. And we'd be really interested to know, what city and time zone are you watching our lectures from? Write it in the comments. We're truly curious. Now, let's get back to our galactic sheep, or rather, the breathing of the Milky Way. So, we know this mysterious wave rolls through the Milky Way. But what causes it? What makes our galaxy sigh so deeply and rhythmically? Listen, this is a question that haunts humanity's best minds. It's not just a coincidence, not some cosmic cough. It's a fundamental process. The first thing that comes to mind is, of course, gravity. Good old gravity. The force that calls the shots in our universe, that keeps us on Earth and planets in orbit around the Sun. It's the grand architect that creates stellar islands and cosmic networks. You can imagine the galaxy as a vast carpet stretched through space, with stars and planets as marbles rolling across it. Gravity creates dents, curvatures, which guide their movement. And when this carpet itself starts to vibrate, that could cause a wave, right? But is visible gravity alone, coming from stars, gas, and dust, enough? Scientists are like, well, in theory, yes, but here, we return to our dark matter, the very thing Zwicky talked about. Remember, it's invisible, but it possesses gravity, and there's much more of it in the galaxy than everything we can see. 5 times more. Imagine, our Milky Way isn't just a cluster of stars. It sits inside a massive invisible bubble, or, if you prefer, a jelly of dark matter. It's like a transparent, yet very dense sphere that holds everything together. So this dark matter isn't just a static backdrop. It's also susceptible to influence, and can itself be a source of perturbations. What if this invisible framework, this cosmic jelly, also oscillates? What if our galaxy, like a boat sailing on an invisible ocean, creates ripples in this dark matter ocean, or conversely, is itself affected by its unseen currents? It's as if you were sailing a boat on a lake, but beneath you was another layer of invisible, yet very dense water, and waves could travel both on it and through it. These waves of invisible substance could then transmit to our visible galaxy, causing those very pulsations. But wait, what if it's something else? What if it's not just the gravity of visible or even dark matter? Physicists are restless individuals. They're always looking for something new, something beyond the known. Perhaps gravity doesn't quite work the way we've imagined on galactic scales. Perhaps there are some modifications to general relativity that only become apparent in such colossal systems. Or perhaps dark matter itself isn't as simple as it seems. What if it has some intrinsic properties that allow it to orchestrate such large-scale size? Perhaps it's not just a passive gravitational background, but an active participant in the cosmic dance. This isn't just a mystery, it's a true detective story. Where do these giant waves come from? It's the heartbeat of the cosmic ocean, and we're trying to understand what gigantic, invisible entity makes it beat. We see the symptom, the wave. But we're searching for the cause, that invisible, fundamental thing that governs this entire cosmic symphony. Imagine this, 1816. Europe and North America plunged into chaos. The year without a summer unexpectedly arrived. People shivered in mid-June, rivers froze in August, harvests perished, causing famine and mass migrations. And the cause of it all was the eruption of Mount Tambora, which occurred in distant Indonesia in 1815. Ash, ejected into the atmosphere, wrapped the planet in an invisible blanket, changing the climate for months, if not years. It seemed like such an insignificant detail, such a distant cataclysm, and yet how profoundly it affected the lives of billions. Similarly, if you're enjoying our cosmic journey through the mysteries of the galaxy, don't forget to hit that like button and subscribe to the channel. It helps us create more engaging content. And tell us in the comments, what city and time zone are you watching our lectures from? We're very curious to know where our stargazers live. Meanwhile, let's return to our cosmic volcano, which is much larger than Tambora. Because the galactic wave we're talking about isn't just a beautiful ripple on the stellar ocean. It's a colossal, invisible impulse capable of redrawing the map of the Milky Way. Like a skilled landscape designer rearranging shrubs in a garden, or an experienced gardener shaking a tree to make ripe fruits fall off. You know what's most intriguing? This breathing of the galaxy can influence the most fundamental processes around us, from the birth of new stars to the fate of planets. Remember, we talked about star formation? Imagine you have a huge bag of sand. If you just gently shake it, the sand will start to condense in some places and disperse in others. In the same way, the wave compresses clouds of gas and dust drifting through space. It compresses them, like a cosmic bulldozer. These compressions become the cradles for new stars. Yes, it's not an instantaneous process, not a fireworks display every evening, but over millions of years, this wave can significantly increase or, conversely, slow down the rate of star formation in certain regions of the galaxy. And more stars mean more potential planets, more chances for new life. But that's not all. What about existing star systems? So what? Our planets are firmly tied to the sun, some wave out there won't move us, the skeptic will say. And they'd be partly right, but only partly. This wave won't knock Earth out of its orbit, but it can, metaphorically speaking, give it a barely noticeable yet constant nudge. Imagine you're sailing a boat on a lake. Small ripples won't capsize your vessel, but if they come constantly, they can slightly alter your course, imperceptibly shifting you towards another shore. Such nudges from the galactic wave can affect the long-term stability of planetary orbits, and that's critically important for life. A slight shift, and suddenly that planet, which was previously in the so-called habitable zone, where water can exist in liquid form, finds itself too close or too far from its star. Hello, desert, or eternal permafrost. Or conversely, a planet that was previously uninhabitable suddenly finds itself in more favorable conditions. A true cosmic roulette. And then there's the Oort cloud, a giant spherical shell of icy objects surrounding our solar system at a vast distance. You could call it our cosmic refrigerator, full of comets. Gravitational perturbations from this wave can, as if someone's hand carelessly nudged a shelf of jars in a pantry, disrupt the equilibrium in the Oort cloud. This could send comets into the inner solar system, increasing the likelihood of collisions with planets. Not necessarily the end of the world, but it certainly doesn't add to peace of mind. Thus, the breathing of the galaxy isn't just a pretty name. It's a real, grand mechanism that influences how stars are born and die, how planets dance around their suns, and even where and in what form life might emerge or fade away. Our galaxy isn't just a backdrop, it's an active player. and we are just tiny passengers on its enormous pulsating ship. Imagine the summer of 1932, Belleville, New Jersey. Karl Jansky, a young but already devilishly meticulous engineer, sits in his laboratory. His ear, a huge rotating antenna resembling a futuristic carousel, is tuned to search for sources of radio interference. He expects to hear the noise of local thunderstorms or distant transmitters. But instead, through the static hiss, once a day, a strange, pulsating sound emerges. A sound that first annoys and then makes your heart skip a beat. It wasn't Earth. It wasn't even the sun. This hiss came from the very heart of our Milky Way. Jansky was the first person to hear the galaxy. He taught us to see the invisible, using entirely different eyes. Listen, if this story and our journey through space resonate with you, don't forget to subscribe to the channel and hit that like button. It's our fuel for future discoveries. And while we're unraveling galactic mysteries here, tell us, what city and time zone are you currently watching our lectures from? Write in the comments. We'd love to know the geography of our explorers. Now, let's get back to our cosmic ear and how we learned to see the invisible movement of entire galactic masses. So Jansky heard the galaxy, but how do you see a wave that passes through trillions of stars? How can you even detect something so grand, yet so subtle, that it blends in with the chaotic movement of billions of celestial bodies? You're probably thinking, well, they just pointed the most powerful telescope and saw the stars swaying like floats on water? Ha! If only it were that simple. Imagine trying to figure out if an entire ocean is moving right or left by watching thousands of individual seagulls taking off, landing, and just circling above the water. Difficult, right? Because we don't see the wave itself, like a tsunami on Earth. We see the result of its passage. We catch its traces. Like true detectives, scientists don't look for direct evidence, but indirect proof. We can't see the wave as we see ocean ripples. We see how the stars caught in its path begin to behave a little differently. A little faster, a little slower, slightly to one side. It's as if you were looking at a vast field of sunflowers and suddenly noticed that not just individual flowers were swaying in the wind, but entire rows had begun to synchronously, yet very, very slowly, lean in one direction. And that's where our cosmic superhero enters the scene, the European satellite Gaia. Imagine it orbits and meticulously, with mind-blowing precision, measures the position, distance, and motion of over 1.5 billion stars. That's not just a little. That's an entire galactic census taker. Its precision is such that it can measure the diameter of a human hair from 1,000 kilometers away. Do you understand the scale? Such meticulous work isn't just about looking at pretty pictures. This is astrometry in its purest form. Gaia measures microscopic shifts, billions of such shifts. Then scientists gather all this data, like tiny pieces of a gigantic puzzle, and start looking for patterns. And that's when this invisible yet majestic wave begins to emerge. This isn't chaotic motion, it's a coordinated oscillation of billions of stars, stretched across thousands of light years. As if, in one enormous, slow dance, the entire galaxy took a step to the side. Of course, skeptics would immediately exclaim, "That's just statistical noise. Stars are always moving." And they would be right, if that movement were random. But when billions of stars in different parts of the galaxy start moving simultaneously and in the same direction, that's no longer noise. That's a symphony. A symphony we've learned to listen to, not with our ears, but with the eyes of the most precise instruments ever created by humanity. These are our eyes in space, and they show us that the Milky Way isn't just alive. It breathes. Imagine this: Washington, April 26, 1920. The National Academy of Sciences, the hall packed to the brim. The atmosphere was charged, like before a boxing match, only instead of gloves, there were theories, equations, and observations. In the ring, two titans of astronomy, Harlow Shapley and Hubber Curtis. The subject of their dispute? The entire cosmos. Was our Milky Way the only galaxy, or did other island universes exist beyond its boundaries? It was the Great Debate, a clash of two worlds, two visions of our universe. One argued that the entire universe fit within our galaxy, and nebulae were merely gas clouds inside it. The other insisted these nebulae were independent, distant galaxies, as vast as our own. Imagine they argued until they were hoarse, until their faces were red, about the sheer size of our cosmic home. This wasn't just a scientific discussion, it was a revolution in thinking, waiting for its moment. And you know what? Similar intense, painfully familiar debates that change our understanding of the cosmos are happening even now. Before we dive into a new battle of giants that literally made scientists scratch their heads in bewilderment, if you like this video and our approach to astronomy, don't forget to hit that like button and subscribe to the channel. It really helps us create more such fascinating stories. And while you're clicking away, please tell us, what city and time zone are you watching our lectures from? Write it in the comments, we'd love to know. Now, let's return to our cosmic battles. Today we know the galaxy breathes. But this discovery didn't fall from the sky like a cosmic meteorite. Oh no. It was wrested from fierce debates, where every data point was questioned, and every hypothesis subjected to ruthless criticism. Scientists, like detectives at a crime scene, tried to make sense of indirect evidence. When the first hints of a wave appeared in the data, the reaction was predictable. That's just statistical noise, measurement error, some strange artifact in the telescope. Imagine you're looking at a huge, perfectly smooth table, and suddenly you notice a barely perceptible ripple on it. But painstaking, meticulous work, with numbers, with hundreds of thousands, millions of stellar coordinates. It's like assembling a gigantic cosmic puzzle, where each tiny star is a minuscule piece. And when you arrange millions of these pieces, you suddenly realize they form a completely unexpected picture, a wave. Scientists were able to show these ripples, this whisper, are not random. They follow a specific pattern, have a concrete amplitude and direction. This was proof, undeniable. And then the skeptics, those very ones who initially wrinkled their noses and shrugged, began to reconfigure their models. Because in science, nothing is more convincing than ironclad data. It wasn't just someone changing their mind. It meant the collective intellect of the scientific community took a step forward, embracing a new, more complete picture of our amazing living galaxy. The battle was over, and truth prevailed. England, 1687. In the quiet studies of Cambridge by candlelight, a young but already brilliant Isaac Newton toiled over a manuscript that would forever change our understanding of the universe. His Principia Mathematica, wasn't just a collection of formulas. It was a ticket to a new era where magic gave way to mechanics. And you know what was one of the most astounding demonstrations of his theory? The explanation of tides. For thousands of years, people looked at the ocean, saw the water advance and retreat, and wondered, is the moon casting a spell? Is it the breath of a sea monster? Newton proved it was simply gravity. No magic, just the universal law of gravitation, which the moon exerts on our planet, stretching its watery envelope. As we delve into these cosmic mysteries, don't forget, if you like this video, to hit that like button and subscribe to the channel. We'd really appreciate it, and you won't miss new amazing stories. By the way, what city and time zone are you watching our lectures from? Write it in the comments, we'd love to know. So, when we talk about the breathing of the galaxy, about that very wave piercing the Milky Way, we inevitably imagine something familiar, something from our earthly lives. And the closest comparison, of course, is ocean tides. Imagine you're standing on the seashore and you see the water slowly but inexorably retreat, exposing rocks and shells, and then just as majestically advance again. It seems so fundamental, so natural. Now imagine the same principle, but on a galactic scale. Instead of a watery surface, billions of stars. Instead of the moon, whose gravity pulls the water, an invisible but colossal force that distorts the very fabric of our galaxy. Hold on a minute, the skeptic will say. That's completely different. Water is a liquid. It deforms easily. But stars? They're giant balls of fire, separated by unimaginable distances. How can you compare them to ocean waves? And the skeptic, by and large, is right. Stars aren't water molecules, they don't dance so freely. But listen, the fundamental principle remains the same. Gravity. Remember how the moon's gravity creates tides? It pulls the side of Earth closer to the moon more strongly than Earth's center, and the center more strongly than the far side. This is where the stretching effect comes from. Well, similar tidal forces are at work in the galaxy, only their source is far grander and more mysterious. The galaxy isn't a static disk. It pulsates, breathes. Imagine the Milky Way isn't just a flat pancake, but rather a gigantic jelly-like mass that slowly, almost imperceptibly to our eyes, oscillates. Somewhere deep inside, or even from outside, some colossal event occurred. Perhaps a collision with a dwarf galaxy, or even the influence of dark matter itself, which created the ripple. It's as if you threw a huge stone into a cosmic pond. Only instead of water splashing, a wave of compressions and rarefactions ripples through billions of stars. These aren't just stars flying up or down somewhere. These are entire stellar streams, gigantic stellar rivers, collectively synchronizing their movement, as if an invisible conductor waved a baton and a vast orchestra of stars began to move in unison. The wave moves, the stars follow. Think about how a tsunami wave, born somewhere in the ocean, can travel thousands of kilometers before crashing onto a shore. It seems slow, invisible in the open sea, but it carries colossal energy. So too with this galactic wave. It propagates at a speed that, on cosmic scales, is quite fast, but for us, living on one of its tiny specks of sand, it's a process that lasts millions of years. So yes, we can compare it to ocean tides. Just multiply the scale by trillions, and replace the water with billions of stars. And there you have it. A cosmic ocean that obeys the same fundamental laws as a tiny puddle in your backyard. Amazing, isn't it? It was a hot Egyptian afternoon in July 1799. French soldiers of Napoleon were digging fortifications near the town of Rosetta, when suddenly their shovels struck something hard. From beneath the earth, they unearthed a basalt stone, darkened by time, covered with strange writings. 3 different scripts inscribed on a single slab: Greek, ancient Egyptian hieroglyphs, and demotic script. For 200 years, the world had struggled with the mysteries of Egypt, and then, such a gift. No one knew it then, but this stone would become the key that would unlock all the secrets of one of Earth's oldest civilizations. You know why I bring this up? Because right now, we're finding a similar Rosetta Stone, right above our heads, a wave passing through the Milky Way that is the key to our galaxy's DNA. And before we delve into these galactic mysteries, let me briefly pause. If you're enjoying our journey through space, don't forget to hit that like button and subscribe to the channel. It really helps us create more content like this. And one more question. What city and time zone are you watching our lectures from? Write it in the comments, we'd love to know. Now, let's return to our cosmic archaeology. Imagine our galaxy is a huge, ancient book, written in a complex, incomprehensible language. Until recently, we only saw the cover and some illustrations. But this wave, this cosmic sigh, it's as if it's shaking the pages, and suddenly, previously unseen words, entire chapters, begin to appear. We're talking about how this ripple, this oscillation, is a direct imprint of our galaxy's past. How does this work? Well, listen. The galaxy isn't just a collection of stars flying in a circle. It's a complex, dynamic system that is born, grows, interacts with neighbors, sometimes even devours them, like a predator devouring its prey, leaving traces, scars on its body. And these waves, these are those very scars, or if you prefer, tree rings of our galaxy. Each such ring, each such ripple, is evidence of some major event that occurred in the distant past. That's just an echo, the skeptic will exclaim. An echo that tells an entire story, we'll reply. Remember the pond into which a stone fell. The ripples spread out, fade away, but their shape and speed can tell us how big the stone was and where it fell from. And our galactic wave, it's a similar gigantic echo from a cosmic stone that once fell into our galaxy. It's highly probable that the cause of this wave was a collision or close interaction with another, smaller galaxy. Perhaps with the Sagittarius dwarf galaxy, which is slowly but surely being absorbed by the Milky Way. Its gravitational influence is that very stone. And the impact was so powerful that its echoes are still reverberating through billions of stars. This wave isn't just a beautiful phenomenon. It's living proof of galactic cannibalism. Listen, it's like a forensic expert who can reconstruct an entire crime scene from a single fingerprint, or a geologist who reads the Earth's history over millions of years from layers of rock. By looking at this wave, we read the history of the Milky Way over billions of years. It tells us about the past, who we danced or battled with, about the present, how these interactions shaped what we see now, and about the future, where we're headed. Imagine this wave isn't just an imprint of the past, but also a kind of seed for the future. When the wave passes through gas and dust clouds, it can compress them, triggering new bursts of star formation. It's like hitting a drum that starts a new melody. So the breathing of our galaxy doesn't just tell us about its DNA. It actively participates in its formation, influencing the birth of new stars, and thus the potential appearance of new planets and possibly new life. It's not just a wave, it's a cosmic pulse, a recorded chronicler, and each of its beats tells us who we are, where we came from, and where we're headed in this immense cosmic dance. We're deciphering not just the movements of stars, but the very genetic information of our galactic family. And this, my friend, is just the beginning of reading this amazing book. July 1923. Atop Mount Wilson Observatory, in the cool mountain air of California, a man named Edwin Hubble sat before his photographic plates. He peered at the hazy, indistinct smudges then called spiral nebulae. For a long time, no one could decide. Were these just gas clouds within our Milky Way, or something much larger? And then, on one of the plates, featuring Andromeda, he saw them, Cepheid variable stars. And this meant only one thing. Andromeda was beyond our galaxy. It was an independent stellar island. Imagine that moment. A world that had seemed finite and understandable just that morning suddenly expanded to unimaginable scales, revealing an endless ocean of other galaxies. This wasn't just a scientific breakthrough. It was a slap in the face to human hubris, and at the same time, the greatest invitation to look beyond the horizon. We really love that you continue your journey through cosmic mysteries with us. If you appreciate our efforts and find these captivating stories interesting, please subscribe to the channel and hit that like button on this video. It's the best gratitude for us. And also tell us, what city and time zone are you watching our lectures from? Write it in the comments. We'd be interested to know our cosmic audience. Now, let's get back to our topic, because after every mystery solved, there's always a new, far more intriguing one. Because, listen, that very wave we've been talking about, this galactic ripple piercing the Milky Way, it's not the final page of the cosmic book. It's just another bookmark. We've solved one huge riddle, but 10 new ones are already looming. Scientists are probably like, great, we just figured out the wave, and now 33 new mysteries have popped up. And that's wonderful. You know what awaits us beyond this wave? Firstly, of course, an even deeper understanding of one: dark matter. We've already discussed how the invisible gravitational architecture of this mysterious substance dictates the rules of the game for stars and gas. And the galactic wave, like a gigantic fingerprint, can give us invaluable clues about how dark matter is distributed within our Milky Way. It's like trying to sense an invisible fish in dark water, orienting yourself by the waves it creates. The cosmic detective story continues. With each passing year, our instruments become more precise. New telescopes, such as the upcoming James Webb Space Telescope, will be able to peer even further, seeing the movement of stars with unprecedented detail. This means we'll be able to not just confirm the breathing of the galaxy, but literally listen to its cosmic musical score, to catch not only the main notes, but also the subtlest nuances. And of course, questions remain about interaction with neighboring galaxies. The Milky Way doesn't exist in a vacuum. It's part of a giant cluster. Our galaxy is constantly communicating with the Magellanic Clouds, with the Andromeda Galaxy, which, by the way, is hurtling towards us to stage a spectacular merger 4.5 billion years from now. This invisible galactic breathing might not just be an internal phenomenon, but a result of these cosmic dances. Imagine throwing a stone into a pond, and waves spread across the water, colliding with waves from a neighboring pond. Complex, extremely, but incredibly fascinating. What other mysteries await us? Perhaps we'll learn that such waves aren't an exception, but a Bakunin constant mechanism of galactic evolution, that they regularly sweep through stellar islands, mixing gas, triggering star formation processes, and redistributing matter. It's like an eternal renewal, a breath that sustains the life of the entire stellar metropolis. This is an endless cycle of discoveries. Each solution leads to a new horizon of questions. We've only just learned to hear the galaxy's pulse. But what if this pulse is part of a much more complex polyphonic choir, where each galaxy sings its own song? Imagine we've only just discovered the existence of an orchestra, but haven't yet understood what instruments are playing in it and what melody they're performing. Future research will be precisely about this: finding other instruments, dissecting the complex harmony, trying to understand the complete roadmap of our galaxy, from its birth to its inevitable collision with Andromeda. We are turning the pages of a gigantic book, and each new chapter reveals even more astonishing things. The galaxy breathes, and we, armed with curiosity and new technologies, are ready to hold our breath in anticipation of new discoveries hidden beyond this wave. And this, believe me, is just the beginning.